Today we're going to talk about how to use RTBricks bngBlaster to emulate BGP session and also send some routes. The setup I have is an RTBricks which is installed on an Ubuntu that is connected to a Juniper router. And what I'm trying to do is try to configure BGP session between the Juniper and the RTBricks server to emulate a BGP session and try to send some routes and to also withdraw some routes. You can use this for scenarios where you want to scale your setup for testing or checking something. You could use RTBricks to pretty much send how much ever routes you want, and you will be able to create a scenario where you want to send periodical updates, withdraw some routes. All that is possible through RTBricks. So we will look into those options. So quickly going through the configuration. So there are some wonderful documentations for RTBricks bngBlaster. So this is in the RTBricks GitHub page. Under routing protocols, under BGP, they have examples of how to configure BGP and the relevant knobs that you can use. One important point with RTBricks is there is a raw update file generation. So you pretty much have this BGP raw update that you will have to install using SCAPI because it's using libraries of SCAPI, and you can create your update files, and what you can do is you can use that to be referenced in your BGP configuration file. So let me show you what I mean by that. So here this document has that example. As you can see, they are calling the raw update file here as a reference, and you can also load some additional files if you want to use that as a update or withdraw scenario. Now to generate the BGP prefixes, this BGP raw update generator, there is also a syntax given as explained here, BGP update help. So we are pretty much using that syntax to generate all the routes that we want. As you can see here, the syntax is explained. I will explain what I'm doing based on this example and reference. So now quickly going through one more important part before we start the demonstration is once you understand the BGP logic in RTBricks, there's one more important tool, the bngblaster CLI. So this is something you can install as a part of an additional package, and the benefit is you can check the session status and even a lot more other details that you can find out. Again, some good references and examples are given here as to what bngblaster CLI is all about. So now quickly jumping into the scenario that I want to test. So as we were talking, this is the Juniper router that is connected directly to the bngBlaster. Now my neighbor right now to the bngBlaster is down. As you can see here, the state is idle. And first things first, I go log into the RTBricks and I have the steps that I want to demonstrate here. So what I do is I've created a file to explain what I've set up. So I create some update and withdraw files. That is my first step based on the documentation I had given. So I've created a BGP update. -f is the file name, A.bgp, which I will reference. -a, according to the syntax, is the local AS number, the local preference, the next stop for my routes, the number of next stops I want. In this case, I want all my routes to point to a single next stop, the prefixes that I want, and the total number of prefixes. This is the syntax. Now what I'm doing here is I've created two files. A is the first set of updates that I want my BGP session to establish and send. Then I create a B update file, which I will manually trigger an update just to demonstrate that. And you can see here, all the parameters are almost same except the prefixes are from 20. The first updates will be on 90 and the second updates will be on 20, which I will manually trigger it through a command. Likewise, I'm also creating a withdraw file. So for this 20 prefix, I'm also creating a withdraw file. Notice that syntax is almost the same. The file name is slightly different, obviously, but the key for withdraw routes is you have to add this flag at the end. Now to start your RTBricks BNG, the command is bngblaster-s run.sock. This is a sock where you could check the status of your BGP. -c is nothing but the configuration file. In this case, I call it GAT. -i is interactive. -l BGP is log the session status. Just a file name here. Now the key part is I'm just opening up my configuration file. Now if you look at my configuration file, I have an interface on the configuration file. This is the network emulating interface, ENS20, which has got an IP address and a gateway. In this case, the gateway is the Juniper. Now the BGP configuration is very simple. Local address is my local network interface address, as you can see. The peer address is the gateway, which is the Juniper. The local AS, the peer AS, and the raw update file. You can see that I'm referencing the first raw update file, which is A.bgp. And the family that I'm trying to simulate or establish a session is, this case is IPv4 unicast. There are other families that you can establish session. It is clearly mentioned on the documentation. And I'm also informing the network interface is ENS20. Now let's start the BGP session using the syntax that I have here. So I first go and so I need to be in super user because I have installed my bngblaster in super user mode. So what this is doing is creating an interactive session. As you can see here, the logs are telling my session has established from open confirm to established, and the updates started and updates stopped. So updates are sent. Now let's check the BGP status. So if I check the BGP status now, you can see on the Juniper, the BGP state is established and I have 10 routes that I have received. Now let's check what routes we have received from the neighbor. As expected, we have received 10 90.prefix routes. Now, the next thing is after we've done this, so what if we want to check? I have one more window to the RTBricks. So how do I check the status of my BGP session? So I have started my BGP using this command. It has sent updates from a file. Now to check the status of BGP, you can use this command. So what this is doing is telling me that from RTBricks, the session is up. As you can see here, the state is established. Now let's try to do the next bit of things where you want to push an incremental update. Now to do an incremental update, I know I have a file called b.bgp, and then we will simulate a withdraw as well. To do an incremental update, this is the command. bngblaster-c run.sock bng raw update and the file name. So first what I'm going to do, I'm going to call the file name b.bgp. So this means I should send, in addition to 90 prefixes on the router, I should also get 20 prefixes. That is the 20.1 prefixes. So here I'm pushing the update. You see it started, everything seems okay here. And now if I check here, you can see in addition to 90, I've also got another set of 10 routes from the 20 range. So the total route count, if I look at my neighbor session, is 20. Now if I want to withdraw these 20 routes, the command is the same, but just I call the withdraw.bgp, because you remember we have given the keyword withdraw at the end of this config file or the update file. So here I'm withdrawing those routes, and now if I check on the total route count, it should be only 10, and I expect the 20 prefixes to be disappearing. Here you go. So you can see this is a very powerful tool that can be used to simulate BGP when you're testing route reflector functionality or you're doing some kind of scaling or any kind of testing. You can use RTBricks to simulate routes. There are a few additional examples that I'll post on another video which talks about, in addition to sending these routes, you can also send traffic to these prefixes. So we will talk about it in another video. Bye for now. Hope this is useful.